Hello, hello, hello. If you're watching this, you missed day one of our week 14 lecture in computer science principles. Let's get to it. So we are continuing our exploration of conditionals, but this time more practically. So last week we did very theoretical, kind of high thoughts, how does this thing fit with this other thing type of deal. Today we're going to look at very, very real applications. How do we actually make the computer do this stuff for us? How does the computer evaluate a Boolean expression? What can we make it do using these things? We're going to do an exploration, and then you guys have an assignment for me. There are two things coming up. One is the conditionals assignment, which is due Wednesday the 2nd. The second one is a journal assignment with terms, and that's due Wednesday the 9th. That's next week. I'm hoping that you can recognize the need for programming patterns and expressions with conditionals. You can implement them, write comments to clearly explain parts of your code that are complex, and use debugging skills as part of your development process. Let's see what we're up against here. So we did a quick warm-up where I had you guys draw some quick flowcharts. So hopefully you can do that. Next, this is an important point. In real life, whenever you say when, you should think, as a programmer, you're probably going to need an on event to process that if you're a computer. So when I click a button, I need an on event. When I press a key, like the space key, for instance, I have an on event that then does something. Well, the keyword if is similar. If I say if, that should set off alarm bells in your head saying, oh, that's probably a conditional coming up. If I'm old enough, I can go on the ride. If it's Saturday, I don't have to go to work. All of these are conditionals, and they have a Boolean value or expression, and that needs to be evaluated in order to determine the validity, and therefore the path your program will take. There's a bunch of videos. I will not show them to you. Please watch these on your own. They're posted in the PowerPoint that is available on my MCPS. We started off by doing an exploration activity that's posted on code.org underneath lesson 6. Take a look at this game here. Then essentially figure out what it does. So you chase a lemon around. If you hit the lime, you lose a life. Now, if you scroll down here, you find our very first conditional statement all the way at the bottom. It's important to understand what the rest of this code does as well. This first part right here initializes the variables when you press the play button. It's important for you to know that word, initialize. Put a starting value to these variables. Next, we have what happens if we hit the lemon. Well, the lemon moves somewhere randomly that is bounded within the screen using these numbers, and we get a point. If you touch the lime, you lose a point, or sorry, you lose a life rather. Lemon and lime move, and if we ran out of lives, we lose the game. Now, originally, this thing here does not read what I have written here. Originally, it says this. That is incorrect. If you hit 0, 0 is not less than 0. So you can keep playing with 0 lives, which you probably don't want. So you can fix that by either saying less than or equal to, or changing this to a 1. Either option will give you the right answer. The next kind of version of this game is a little bit augmented. It has an if-else structure. So if-else structures allow you to have multiple outcomes, and you can check for different things being true within them. So here we have one where every time we get a certain number of points, we're going to shrink the size of our lemon to make the game more difficult. So as the score gets larger, the lemon gets smaller until past 15 points, it's really, really small. So hopefully you guys understand this structure. If not, please feel free to come after school or during Wednesday, and I'd be happy to explain it to you further. Lastly, you can use and or operators, similarly to how we've talked about before, but now we're using them inside these if statements. So you can say if the username, which we've added here, and the password together work out, then we get to play the game. If they don't match, that means that and statement will not evaluate to true, then we can't play the game. So nothing too crazy, very straightforward. If these don't make sense to you, please watch the videos that are posted in the PowerPoint slides on my MCPS, and hopefully those will also shed some light on what's going on here. Now, a couple of things that are important to point out. A very common mistake is misplacing which check you do first. This is the proper order right here, checking the highest temperature, then each one being lower if you're changing their temperature to be larger than a certain threshold. If you were to switch these, let's say, and check to see if temperature is more than 90 first, well, any temperature that's more than 100 is more than 90. So you would accidentally catch too much in that if check. And then if the temperature is greater than 100 was here, it wouldn't be effective because every case where that would be true would be already accounted for above it. So you have to be very, very mindful of what order you do your conditionals in. That is a very common mistake. Now, there are two kinds of errors that you're encountering, guys. Syntax errors are really simple. That's when you mistype something. You forget a semicolon. Your variable doesn't exist. Anything like that. The logic errors are the tough ones. What I just pointed out would be a logic error. Writing if-else statements in the wrong order, updating the property of a wrong element. These don't cause your program to have an error because there's nothing actually wrong. It's just the result is not what you expected. It's what you wrote, but it's not what you wanted. So these are very difficult to catch compared to these, so be careful of logic errors. Your assignment is to go to code.org. Well, you can also get to it from modules. Assignment 040801, conditionals make, due Wednesday the 2nd. All right, if you click this link, it'll take you to code.org to lesson 8, bubble 2. There's an app here. Play around with the app, see what it does. Essentially, it sells you tickets. Depending on your age, you get a different price. Depending on the day, you get a different price. And there's a special coupon code you can put in here that also gets you a discount. It's up to you to then recreate the code behind this program. It's going to have some conditionals in it, since you need to check for various prices, and it should work just as you saw the app there working. Now, I'm asking you inside this assignment to name all the variables first, create a drawing of a flowchart that represents how you're going to tackle this. There's multiple ways that you could approach it that would be correct. If you have a camera, draw it on a piece of paper, take a picture, and insert the picture right here using Insert Image. If you don't have that capability, simply use Google Draw. Hit Drawing, New, and create your flowchart here. So you probably want to use something like a box to represent your conditional, if blah, then blah. And then you've got, well, you probably wouldn't want to put then in there, huh? You just want to say if something is met, and then use arrows to point to what the outcome should be. And there might be more conditionals on the ends of these arrows, but it should create a nice little table I can follow to figure out what's going on. So there would be two options here, yes or no, and then depending on the outcome, there's two different paths we can take, and so on and so forth. All right, down here is the rubric for the actual code itself. You're going to write the code at this link, which is bubble 3 of lesson 8. And all I'm looking for you to do is recreate the program. I've given you a little starter code here. You need to create your variables, update them, check the values, and go ahead and have your conditionals that figure out what to do. Create the text. Remember, you need to concatenate everything together into your nice, beautiful output. Make sure to use line breaks using /n. And then last but not least, set the screen to the proper output. Hopefully none of that is too crazy. If you have trouble, please, please, please come see me after school. Shoot me an email. I'm always available Wednesday from 9:30 until 3:30. You can always see me then. 2:30. Otherwise, I'll see you next time in class. Have a good one.